Welcome back, guys. In this video we're going to talk about polynomials, and specifically we're going to talk about working with exponents. So right now I'm going to give you 3 rules which you should keep in mind when working with exponents. So first one is when multiplying, when you have 2 numbers which one is negative and then times the other one which is negative as well, the answer is always in positive. So that's the first. The second one is when you have a negative times a positive, the answer will be in negative. And the third one, which is pretty basic, whenever you have positive times positive, it will always be positive. We'll pause it. Let's end that out.
Stop.
And the same rule applies for dividing. So instead of these multiplying, same rule for dividing. So now the trick to memorize this is whenever you have 2 negatives, it's always positive. And same thing here. 2 positives, it's always positive. So whenever you have 2 signs, same signs, it's always positive. And when you have different signs, it's always negative. That's a simple way to memorize this. Now we should do an example. I'll just pause.
Yeah.
So a very basic example we're going to do is negative 10 divided by, let's do positive 2. So 2 equals. Now, I already know the answer to this, but if you do it in the calculator, since this is negative.
Wait.
So a basic example we're going to do is negative 10 divided by positive 2. So now the answer to this I already know, but if you do it on the calculator, then you understand why a positive and a negative and a positive will be negative. So negative 10 divided by 2, if you think about it like a positive 10 divided by 2, that's 5. But since a negative and a positive is always negative, so in front of the 5, you're going to add a negative 5. And you could check on the calculator to verify that this answer is correct.
Alright, so next we're going to cover some exponent rules. This looks like a pretty intimidating list with a whole 7, but it's not too bad once you start to actually get to know them. A lot of them are pretty similar. So the first one is that if you've got 2 things that are multiplied with the same base but different exponents, and they're multiplied, you can add the exponents together. And a similar thing if you're dividing them, but you subtract the exponents instead, right? So in this case, it's x to the n divided by x to the n, and that's x to the m minus n. And the third one is if you have x to the m, and this is in brackets, and then that is raised to the power of n, then that's the same as x to the m times n. So a good way to think about this is that you have the exponent numbers, right, m and n. If you're multiplying, it kind of goes like one level down into addition, right? Dividing goes one level down into subtraction. And the exponents themselves, it goes into multiplication, right? So that's a good way to sort of remember these ones. And also, even if you forget the exact rule, you can still sometimes do equations, right? So for example, if you had x to the 4 divided by x to the 2, you could actually expand that out. I just realized I forgot to say, the dot is for multiplication, because if it was an x, that'd be confusing with the other x's. So anyway, so if you think about it this way, right? It's x to the 4, which is 4x's, and x to the 2, which is 2x's, and they're divided, right? So because you have the same variable on the top and bottom, you can cross them out, and now you know that x times x is going to be equal to x squared. So even though I didn't actually use the exponent rule, it still worked out. Or if you actually just remember the exponent rule, 4 minus 2 is 2. So that's how you get x squared here. So the next rule, or the next two rules, are sort of like the distributive property, which I think you should already know about. But here's the thing, right? If you've got x times y, and both of them are raised to the exponent m, then that's going to equal x to the power of m multiplied by y to the power of m, right? And it's sort of like the distributive property, but instead of it being, Instead of it being distributed to things that are added together, the exponent is being distributed onto the two things that are multiplied together, right? That goes for more than two things as well. But a similar thing goes if they're divided as well. You can put the exponent on the top and the bottom of a fraction if the fraction is raised to an exponent. And that's useful if you've got, like, for example, if you've got something like 2/3 squared, you can actually expand that out into 2 squared, that's not a very good 2, over 3 squared, and that equals 4/9, right? So and that can be useful sometimes. And now, the last two rules, which these ones aren't super easy to think about. You just have to remember them. If anything at all, is raised to the power of 0, then it's equal to 1. 1 to the power of 0, 1. 2 to the power of 0, 1. 3 to the power of 0, 1, etc. It just goes for any number, right? And final one, if you have x to the power of a negative exponent, that's the same as 1 divided by x to the same exponent, but positive. So this one is not easy to explain, but you've just got to remember that.
And this one is kind of weird to understand, but it's actually pretty easy. So basically it's x and this negative m on the top as an exponent. So as you all remember, any number is always divisible by 1. So this x is divisible by 1. So now, as we can change the numerator into the denominator, so what that happens is this x goes in the bottom, so that becomes x, and the m becomes positive. And why is that? Because anytime anything from the top, which has an exponent, goes down, it always changes signs. So if this was a positive m, it would become a negative m on the bottom. But since it's a negative m, it became a positive m on the bottom. And since you always know that anything is divisible by 1 and it's multiplied by 1 as well. So the x, there's an indivisible 1 here with an x in the bracket here. So what that means is when the x went to the bottom,